Hey everyone, Mr. Cummings here, and in this video we're going to be taking a look at an experimental setup to analyze the impulse and the change in momentum of a cart colliding with a force sensor. So we're going to draw the lab setup for this experiment. On the left-hand side we're going to have a force sensor, and we're going to set up that force sensor so that if it's pushed it's going to read a negative force, and if the force sensor is pulled it's going to read a positive force. Meaning when the cart collides with this force sensor, we should be getting a negative reading from the sensor. Smack dab in the middle of this track, we're going to have a cart that's free to roll along the track. So to the right of this cart, we're going to set up a motion sensor, and that motion sensor is going to be able to track the position of the cart and record it as a function of time. We're going to set the motion sensor up so that if the cart moves away from the motion sensor, we're going to consider that to be positive motion, and if it moves towards the motion sensor, that will be considered to be negative motion. We'll then start the experiment by giving the cart a push to the left, giving it an initial velocity of v0 in the positive direction. So now we're going to push this cart to give it that initial velocity. Remember, we're not analyzing the push, we're going to analyze the problem after the push is completed, so the cart is just moving to the left with that initial velocity. And then it's going to collide with that force sensor, and we're going to record that data. And so we see from the position time graph that's on the bottom here is that the cart starts with a positive initial velocity, and it looks relatively constant. After hitting the force sensor, it reverses direction and then has a negative final velocity that is also relatively constant. Around the time that the cart switches velocity here is where our force sensor actually has some data reading, where the force sensor provides a force on the cart reversing its direction. So we're getting that negative force spike graph on that force time graph. So now we're going to look a little bit more closely at the sensor data that we collected during this experiment. So we're looking at the position time graph data here. Now something that we didn't record that we know is the mass of the cart is around 0.26 kilograms. Now looking over here on the position time graph, if we remember, the slope of a position time graph is the average velocity, if we take the average slope. But if the slope is constant, then the average velocity is just the velocity at that over that duration of time. So we use the graphical analysis to best fit a slope to this graph for the first region, and we get that the slope is approximately 0.663, and a unit here would be meters per second. So that's telling us the initial velocity of the cart before it hit the force sensor. The final velocity of the cart would be negative 0.492 meters per second. So we can go ahead and take this data and we can make a bank of information that we can then call upon as we analyze this a little bit more. And we're going to look at the impulse of the cart using this position time graph. So the impulse, or the change in momentum of the cart, is just going to be the cart's final momentum minus the cart's initial momentum. So the mass of the cart multiplied by its final velocity, subtracting the mass of the cart multiplied by its initial velocity. So I went ahead and I factored out that mz term from the VCF and the VC initial, just to clean it up a little bit. And we can go ahead and plug in the numbers that we arranged in our variable bank and then see what we get for the change in momentum of the cart. And we get that the impulse on the cart, or the change in momentum of the cart, is approximately negative 0.30 kilograms meters per second. And now that we got that answer, we're going to just drag our answer from the position time graph over to the force time slide here. And so we know, looking more closely at this force time graph, the area of this force time graph, or the integral of this force time graph, is going to give us the impulse on the cart. So we can see that the area here is negative 0.331 newton seconds, which is the same as kilograms meters per second. And so now just to kind of compare what our force time graph gives and what the change in momentum from the position time graph gives, we're going to do the percent difference here. So we're just going to find the difference between each of these change in momentums, each of these impulses from each graph, and see approximately how close we get. So after computing the percent difference, we get that analyzing the force time data and analyzing the position time data gives us about a 10% difference. So showing the area here lines up with the impulse of the object, just as if we calculated the impulse using the initial and final velocity and the mass of the cart. And that's going to be it on this video going over an impulse and momentum example experiment. Thanks for tuning in, and I'll see you next time.